I want to start today with something that, on the surface
Yeah.
seems incredibly robust. The modern global tech stack.
Right.
I mean, these are the cloud architectures that companies have spent, the last 15 years and billions of dollars optimizing. We call them fortresses.
We do. We love talking about redundancy, availability zones, the 5 nines of uptime.
5 9.
It's the security blanket for every modern CTO.
Right.
So exactly.
But the source material for this deep dive, it's basically a quiet engineer's playbook for geopolitical resilience. And it starts with a premise that, frankly, feels a little insulting at first.
It does.
It argues this fortress is actually a house of cards. And not because the code is bad, but because the foundation is built on what it calls a global illusion.
It feels insulting because we're all trained to think about resilience in terms of, engineering failure.
Yeah.
A server crashes. Okay, it fails over to another rack.
Sure.
A whole data center floods. It fails over to another region. But this playbook argues that we're completely ignoring the one failure mode that code can't fix.
Geopolitics.
Geopolitics.
And the hook here, it isn't about a server catching fire, it's about a necklace. The text uses this analogy of a jeweler's masterpiece. It's beautiful, intricate, expensive. But if one single link snaps, the whole thing is on the floor.
And in our world, that snap, that's the law. The central idea we're unpacking today is sovereign IT. And it's a direct challenge to this idea that a global cloud is safe.
And the sources are pretty blunt about the timeline. They're saying by 2026, this isn't optional anymore.
No. They suggest that by 2026, relying on a single global mesh for your IT is going to be professional negligence.
Wow, professional negligence.
Oh,
That's a heavy statement.
It is. But look at what's happened. We aren't talking about a slowdown. We're talking about what the text calls a total freeze.
A freeze.
A total freeze. One sanction, one data injunction, one new localization law, and your operations in a major economy, say India, Brazil, or the EU, they don't just get slower.
They stop.
They stop. Cold.
Okay, so let's play devil's advocate for a second, because I can hear the architects listening to this and, rolling their eyes. They're thinking, we have disaster recovery plans, we have legal teams.
Of course.
Why is this specifically a house of cards? What is the actual mechanism that breaks the stack?
That is the key question. And it's the difference between, let's say, technical resilience and sovereign resilience. The source breaks it down into 3 specific triggers.
Okay.
Sanctions, data injunctions, and localization laws. Let's take the sanction trigger first because it's the bluntest instrument.
Sure.
If you're running your German operations on a U.S.-based hyperscaler and the U.S. government issues a broad sanction or a specific export control, that U.S. provider is legally obligated to cut the pipe.
Wait, even if the server is physically sitting in Frankfurt?
Even if it's in Frankfurt.
Yeah.
Because the control plane, the brain of the cloud, is operated by a U.S. entity, and that entity is subject to U.S. law. They have to comply.
So it doesn't matter how perfect your Kubernetes clusters are.
Not at all. If the API access is legally revoked, you're just dead in the water.
Okay, and then you have the data injunction. This feels a little more nuanced, but just as destructive.
Oh, yeah. This is what we see brewing in the EU all the time. A court decides the data privacy framework between, say, country A and country B is invalid. All of a sudden, moving a customer record from Paris to a processing server in Virginia isn't just bad practice, it's illegal.
And an injunction hits. You have to stop that data flow immediately.
Immediately. And if your app relies on that flow to function.
And then your app stops working. Simple as that.
And the third one, localization laws, seems to be the one gaining the most momentum, especially in places like India and Brazil.
Right. This is where a government just says, look, if you want to play in our market, the data stays here, the processing stays here.
Exactly. And if your entire architecture is built on a global model where everything shuttles back to some central HQ database, you are fundamentally non-compliant. You're effectively evicted from the market.
So the global illusion is this belief that because the internet is borderless, our compliance can be too.
But the borders are coming back. The walls are going up, digitally speaking.
Yeah.
And the playbook we're looking at today says you basically have 2 choices. You can complain about it, or you can build a basement for your house of cards.
Let's get into the solution then. Let's talk about the basement. The sources pivot from global IT to something they call a patchwork of sovereign pods. Now, I have to be honest, as someone who remembers the pre-cloud days, this sounds like a bit of a nightmare. We spent a decade consolidating everything precisely to avoid having 50 different bespoke environments.
And they acknowledge that pain, yes, it is operationally heavier.
Yeah.
But the argument is that operational complexity is now the cost of admission for doing business in the 2026 landscape.
You can't have a frictionless global setup if the world itself is full of
You
friction.
just can't.
So what exactly is a sovereign pod?
The concept is a minimum viable sovereign pod. And the analogy the text uses, which I think is great, is the spare tire.
Okay, I actually want to push on this analogy a little because usually when enterprise IT builds a backup, they want a perfect replica. They want the luxury sedan.
Right. If the primary site goes down, they want the failover to be identical.
Exactly.
And that's precisely why most of these sovereignty projects fail. They try to replicate the entire global stack in a local region. It's too expensive, it's too complex to maintain.
So the spare tire idea is different.
It's totally different. It's not about luxury, it's about survival. It doesn't need chrome rims, it doesn't need heated seats, it just needs to get you home.
And home, in this context, is just business continuity.
That's it. A sovereign pod is a localized, self-contained IT ecosystem. It has to be able to operate independently if that global umbilical cord gets cut. It might be uglier, maybe harder to update, but it works when the main cloud is legally turned off.
Okay, so that's the theory. But let's get into the actual quiet engineer's playbook because the implementation details here, this is where things get tricky. The source breaks this down into 3 steps. Step 1 is map your exposure.
And the text is very, very specific here. It says, map operations, not countries.
What's the distinction?
Well, most companies look at a map and say, okay, we have an office in France, so we need to worry about French law. That's too superficial.
Right.
Mapping operations means tracing the digital veins of your business. Where does the data actually flow, not just where it's stored?
Can you give me an example of a hidden vein like that?
Sure. Let's say you have a subsidiary in Brazil. You know the data is stored in Brazil. You think you're safe. But your customer onboarding process, it uses a third-party identity verification API that's hosted in, say, Texas.
Ah, okay. So the data is at rest in Brazil, but to actually create a new customer, I have to ping Texas.
You got it. And if the data injunction hits, that ping to Texas fails. Your storage in Brazil is fine, but your Brazilian business is dead because you can't onboard a single new person.
That's an operational dependency.
And you have to map those granularly. The text says granularly today. It's like a forensic audit of your own architecture.
You have to ask, where are my mission-critical clients? Where are the regulatory trajectories heating up? And what are the invisible dependencies, like that API in Texas, that I've completely forgotten about?
It's all about those invisible dependencies.
Okay, so let's assume we've done the audit. We know our weak spots. Now we move to step 2. Build the MVP pod. And this is where the source material gets very technical. They outline 4 specific requirements.
And none of them are easy, but they are necessary.
Requirement number 1, a local cloud provider. The text mentions names like Yada for India or OVH Cloud for the EU. Why specifically these local players? Why not just use, an AWS or Azure region that's already in that country?
This goes back to the legal jurisdiction of the provider itself. It's something we call legal insulation.
Legal insulation.
Yeah. If you use a U.S. hyperscaler's data center in Berlin, you are still potentially subject to U.S. laws like the Cloud Act, which allows U.S. law enforcement to demand data that's stored overseas.
So the data is in Germany, but the keys to the building effectively belong to a U.S. company.
Precisely. For a truly sovereign pod, a true spare tire, you often need a domestic provider that is immune to foreign subpoenas. Yada and OVH are native to their jurisdictions. They provide a legal air gap, not just a physical one.
That makes a lot of sense. It's about who the sheriff is. Okay, requirement number 2 is the one that really stood out to me as a modern challenge, a regional AI model.
This is fascinating, isn't it? It touches on the training lineage of your AI.
Right. Normally, we just plug into some massive model via an API, a model that's probably sitting in a huge data center in Oregon or somewhere.
And that's a huge vulnerability. If your business process relies on AI, let's say, for credit scoring or fraud detection, and that model is hosted abroad, a network freeze kills your entire process.
But the text goes even deeper. It talks about sovereign weights. What does that mean?
It means the model itself needs to be compliant. You can't necessarily use a model that was trained on data that violates local privacy laws, even if you're now running it locally. So you need a kind of purpose-built local model that lives entirely inside the pod.
So we're talking about smaller, purpose-built models, maybe like a Llama or Mistral variant, hosted on that local cloud, totally cut off from the global brain.
Exactly. Inference has to happen locally, and the training, or at least the fine-tuning, must respect local laws. It's a huge move away from the one model to rule them all idea.
Okay, requirement number 3. Data residency and identity management. We've talked about residency, but the identity piece, that feels like the biggest trap of all.
It is the kill switch. No question. We're talking about identity and access management, IAM. It's how your employees log in. It's how your systems talk to each other.
And most companies use a centralized system, right? Like Okta or Azure AD.
Exactly. And if that centralized IAM is hosted in the US and the link is cut,
Nobody in the sovereign pod can log in.
nobody. The servers are running, the data is there, but the doors are locked because the doorman is in America.
That is a terrifying image. So the pod needs its own set of keys.
It needs its own authority to authenticate users. You need a local directory service that can sync with the global one, but crucially can operate standalone if that connection breaks. If you don't have this, you don't have a pod, you have a very expensive brick.
And the final one, number 4, is observability. This sounds standard, dashboards, logs, but I assume the challenge is doing it without breaking compliance.
Blind faith isn't a strategy. That's the line from the text.
Yeah.
You need to know the pod is healthy. But you can't just stream all the logs back to your U.S. headquarters because those logs might contain PII.
Right.
So you need observability that aggregates and sanitizes the data before it leaves the pod.
Yeah.
You need a heartbeat, not the full medical record.
Let's talk about one massive headache we haven't unpacked yet. Data gravity.
The big one.
If I have a pod in India and my global cloud in the US, and I'm trying to keep them somewhat in sync, what happens to the database? If the link breaks and people in India keep writing to the local database and people in the US are writing to the global one.
It's a split-brain nightmare when the lights come back on.
So how do you solve that?
This is where the spare tire analogy gets technically tough. The playbook suggests moving from a simple active-passive model to what it calls sharded sovereignty, meaning the local pod isn't just a backup. It owns the right master for that region's data. User data for Indian citizens lives and is written to the Indian pod first. It might replicate out to the global cloud for analytics, if that's legal, but the source of truth lives locally. You're not trying to sync two masters. You're carving out a piece of the database and saying, this lives here now.
It's the only way to avoid that split brain problem if you're disconnected for weeks or months.
It's the only way. Harder to architect, but it's the only way to make sure the pod can actually function in isolation.
Okay, so we've mapped our exposure. We've built this incredibly complex, legally insulated, AI-enabled, locally authenticated spare tire. Now I get to step 3, the part everyone skips.
Pressure tested.
And the source is brutal here. It says, simulate losing your primary cloud in that region.
And when they say simulate, they do not mean a tabletop exercise where everyone nods and says, yep, that would probably work.
They mean a live drill.
Pull the plug. Literally block the IP ranges of your primary cloud provider at the firewall level of your local office.
Yeah.
And just see what happens.
And what usually happens?
Chaos. Absolute chaos.
What breaks first?
The invisible veins we talked about earlier. Suddenly, the website doesn't load because the fonts are hosted on a CDN in California.
Oh, of course.
The mobile app crashes because it's hard-coded to check an API endpoint in Virginia. The customer support team can't access tickets because their CRM is a SaaS product hosted in the UK. All the little things you never thought were sovereign issues.
And the pass-fail criteria are strict. It's not, did we recover eventually? It's,
did the client notice?
Yeah.
If the client sees a 404 error, you failed. If your internal team has to revert to spreadsheets and email, you failed. The spare tire might be a bumpy ride. Maybe some features are missing. Maybe it's slower. But the car has to keep moving.
The source has a great line for this. It says, if the answer to does it work is we think so, then you have a blueprint, not a solution.
And blueprints are useless in an outage. You can't show a regulator a PowerPoint slide and ask for forgiveness. You need running code.
This brings us to the gut check challenge. The sources suggest a specific action item for listeners, a 30-minute meeting.
It's a gamified stress test. You invite the big 3 of risk, your CIO, your CFO, and your general counsel.
You get them in a room, no slides, no prep, and you ask just one question.
If we lost cloud access in our #1 risk region tomorrow, what's plan B?
And then you just watch their faces.
You interpret the silence. The source says the answer tells you everything. If the CIO immediately says, we switch to the OVH pod, latency jumps by 40 milliseconds, but we stay compliant, you're safe.
But if they just look at each other,
If there's uncomfortable shuffling, or if someone says, well, we'd get a team together to figure it out.
we'd figure it out. The most dangerous phrase in business.
If you hear that, or if you just hear silence, you've found your agenda for the next 2 quarters. Because that silence is the sound of your house of cards waiting for the wind to blow.
It's such a powerful diagnostic. It cuts through all the digital transformation buzzwords. You either have the pod or you don't.
And right now, most companies don't. They're just admiring the necklace and ignoring that one weak link.
As we wrap up, I want to reframe this a bit. Because we've spent a lot of time talking about sanctions, freeze-outs, legal injunctions. It's all very doomsday prepper. But the expert commentary in the text flips this narrative at the end.
It does. It moves from fear to greed, or maybe more accurately, to competitive advantage.
Explain that. How is a backup plan a growth strategy?
Just think about the market dynamics. If a major regulatory shift hits the EU, a massive new data law that effectively bans non-sovereign clouds, what happens to your competitors?
If they haven't built the pod, they freeze. They're scrambling.
They are offline. They're trying to negotiate with regulators. They're trying to build the plane while it's falling. But if you have the pod, you just switch over.
And you're the only one still operating.
You are the only one. So you absorb the market. You acquire their customers. The text is explicit. Companies that build these pods will acquire the market share of competitors who freeze up.
So in a volatile world, stability becomes the ultimate premium product.
That's it. It stops being an insurance policy you hope you never use and starts being a strategic weapon you keep in your back pocket.
It's not if the lights go out, it's about being the only one with a flashlight when they do.
Exactly.
The final takeaway from the source material really drives this home. Strategy isn't built on buzzwords. It's built on backup plans that work when the lights go out.
It's back to basics. The basement is what keeps the house standing.
So here is the provocative thought we want to leave you with today. We've talked about the exposure, the data gravity, the kill switch in your identity management. But ask yourself this about your own organization. Are you currently building a basement? Or are you just admiring your house of cards?
It's a question that really determines whether you survive 2026.
It certainly is. Well, that's it for this deep dive into sovereign IT. We've unpacked the risks, the technical hurdles of the spare tire, and the quiet engineer's playbook.
Hopefully we've given you enough ammo to make that 30-minute meeting very, very interesting.
Go ask the question. Thanks for listening. We'll see you next time.